So, as I've mentioned before, first thing you want to do is a little bit of annotation of your problem. So we've got 46 grams there. We have excess O2, so we don't have to worry about a limiting reactant as we were talking about last time. And it says we produced 70 grams there. Okay, but really, when you get right down to it, this part is a question mark. So, grams to grams, that's a three-step stoichiometry problem. So, first step, go to moles. So, 46 grams times 1 mole over 23 grams for sodium gives us 2 moles. Second step, mole ratio, which is question mark on top of what you already know. So I'm going to have the 2 moles times, there's nothing in front of this, so that's automatically a 1. So 2 moles times 1/2, there's a 2 here, which of course is just 1 mole. And then 3, go back to grams. So 1 mole times, well, what is Na2O2? That's 2 times the 23 plus 2 times the 16, which is 78 grams per mole, which of course, since it's just 1 mole, is 78 grams. So this would be a normal stoichiometry problem. We got grams, wanted to end up in grams, had to do all 3 steps. Where does percent yield come in? Well, it comes in right here. This is what we were supposed to get, 78 grams. But 70 is what we actually got. So how do we get the percent yield? The percent yield is, shall we say, what we got over supposed to. And then times 100 to make it a percentage. Well, in this case, what we got was 70. What we were supposed to was 78. And so 70 divided by 78, and then times 100, basically 89.7%, almost 90. That would be the percent yield. Yes? How's that? Okay? So it's a little bit extra than a regular stoichiometry problem because in reality, you almost never get what the math says you could get if everything was perfect. Because in reality, almost nothing is ever perfect. Like I said, some may still be, in the bowl. Some of it might have fallen on the floor. It's kind of like, honestly, if I have some juice in the morning and I want to wash out the glass, I can pour water in and pour it out, but somehow there's still a little bit of juice somewhere on the inside of the glass. It's hard to get all of it. Not too bad, 90% yield. So 90% of our product we actually were managing to come up with. Now in problem 2, we have how much Na2O2? Sodium oxide in problem 1 would have been recovered if instead of this, it was only 75%. Okay, well again, what we were supposed to get was 78 grams. So that's what 75% would be as a decimal, 0.75. And so basically, the idea here is if the percent yield was only 75%, we would have recovered only 58.5 grams instead of 70 grams. So that's the idea for problem 2. If the percent yield is lower, you're going to recover less. All right, problem 3. Determine the percent yield for the reaction of 58.2 grams of zinc sulfide and 12.8 grams of O2 if 16.2 grams of zinc oxide is recovered. Now, in this case, this will be a limiting, because notice now they gave us both of the reactants. And then again, the real question is, how much zinc oxide should we have produced? Okay, so this is a limiting reactant problem. Problem 1 wasn't, because we only had one amount and we had plenty of the other part. But here we got 2 amounts. So step 1 again is go to moles, but I got to do both of them. So first off, 58.2 grams times 1 mole. Let's see, zinc is 65. The sulfur is 32. So that's basically 97 grams. And so that is 0.6 moles. And then we've got 12.8 grams times 1 mole over 32 grams, 2 oxygens. So that'd be 32. And that one is 0.4 moles. Okay, now we want to do the mole ratio between reactants to see which one is limiting. So I can take the zinc sulfide, 0.6 moles of ZNS, times, here's the mole ratio I'm looking at. I want to look at the oxygen to see how much was needed. And so we're going to have 3/2, because for every 2 moles of this, I need 3 moles of that. So times 3/2, so that would be 0.9 moles of O2 needed. And so then the question is, do I have it? Well, I need 0.9. I only have 0.4. Nope. So the O2 is limiting. If the answer had been yes, I have that, then the zinc sulfide would have been limiting. It's very simple. There's only three possible outcomes. One of them is yes, one of them is no, and the other one is, hey, they just so happen to do the 2-to-3 ratio, just like the equation says, in which case I'm going to use both of them up. All right, so now that I know that, we're going to use the O2 because that's the limiting. So that was point 4. Okay, now I have to look at, because what I wanted was this. Okay, that's the guy I want. So there's my mole ratio, 2-to-3, because the question mark is the zinc oxide. So 0.4 times 2 divided by 3, 0.267 moles of zinc oxide. And then I got to go to grams. So again, zinc 65 plus 16, that's 81 grams per mole. So that would be 21.6 grams produced. That's what it's supposed to be. But I only got 16.8 or 16.2. I didn't get 21.6. So what's the percent yield? Percent yield will be the 16.2 over the 21.6 times 100, which was 75%. So that one I had to do pretty much everything. Do a stoichiometry problem, do the fact that it was limiting because they gave me both amounts, and then figure out the percent yield at the end. All right, last example. Determine the percent yield when 30 liters of C4H10. Can always annotate my reaction. Burns with 200 liters here to produce 96 liters of CO2. Now, this is also a limiting reactant problem, but only step 2 for stoichiometry, because I'm going to go from liters to liters. So I don't need to go to moles and do all of that. So I can just leave everything in liters to compare. Yes? Step 2 is just the mole ratio step. Okay? Just mole ratio step. In other words, I don't need to go to moles first, because that would be divide by 22.4, and then at the end, go back to liters, which would be multiplied by 22.4. Instead, it's just going to be step 2. Yes? So, first, we still got to figure out the limiting part, but since they're both in liters, I can go straight to the mole ratio step. I'm going to take my 30 liters of C4H10 times my mole ratio between the reactants is 13 over 2. So that's going to end up with 195 liters of O2 needed. If I use up all 30 liters of the C4H10, I need 195 liters. Okay? So, do I have it? Well, I got 200. So, yes. Therefore, the C4H10 is limiting. When I have enough, then the other one is limiting. When I don't have enough, as I did in the earlier problem, then that's the limiting one. All right, now I can go find, well, how much CO2 should I have? So I'm going to use the limiting one, the 30 liters of the C4H10 times, now my mole ratio, that's my question, that's the question part. So I'm going to have 8 over 2, which is 4, which means this is 120 liters of CO2 produced. Or I should say, should be. But I didn't produce that much. I only produced 96 liters. So, percent yield will be 96 liters over 120 liters times 100, which is 80%.